Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to fluid mechanics, particularly hydrostatics or fluids at rest. So far we have discussed various concepts related to fluids at rest. In this video, we are going to discuss about another important concept related to hydrostatics or fluids at rest, which is capillarity. So before we discuss this, we will just have a quick recap of the concepts which we have discussed. So first we discussed intermolecular forces, okay, cohesion and adhesion. Then we discussed about surface tension and surface energy in different separate videos, but more or less they were interrelated. And then we discussed about angle of contact. So all of these were related to the other. So you had to understand intermolecular forces to understand surface tension and surface energy, and you have to understand these two, intermolecular forces, cohesion, adhesion and surface tension, to understand angle of contact. Now when these three effects are combined together, we will get what is called as capillarity. So you have to understand cohesion, adhesion forces, surface tension and angle of contact to understand capillarity. That's why I discussed all of these things before. Okay, they are important in themselves, these concepts, but they are interdependent on each other. So we know that there are two types of intermolecular forces, cohesion and adhesion. I have discussed it in separate videos, so please watch those videos, because here I will just be gliding over these concepts quickly to go to capillarity. Okay, so cohesive force is the forces of attraction between molecules of the same substance, be it liquid, solid or gas. Adhesion is the force of attraction between molecules of different substance, especially it is used to deal with liquids placed in a solid container. So these are the adhesive forces between molecules of different substance. And another important thing associated with this is the surface tension phenomena, which is the property of liquids at rest by virtue of which they behave as a stretched membrane and are gradually a little bit pulled downwards, they're bent downwards, or in some cases they're bent upwards, leading to concave and convex meniscus. It is because of the cohesive force between molecules of the liquid, the imbalance between the cohesive and adhesive forces, and also because of the less air pressure exerted at the top, leading to a gradual little bit of downward pull or bending of the liquid surface downwards. That is surface tension. Another important thing is the angle of contact, which is the combined effect of cohesion, adhesion and surface tension, because of which liquids, when they are placed in a container, they have concave or convex meniscus, and leading to different kinds of angle of contact, basically two types, acute and obtuse. Acute lesser than 90 degree, obtuse greater than 90 degree. So this is the angle between the tangent which is drawn to this curved surface, okay, whether it is concave or convex, and what that angle between the tangent drawn and the point or the interface or the boundary where the liquid touches the solid. The angle between the tangent and the boundary is the angle of contact. So these are the three important concepts. So where does capillarity come into play? Capillarity basically is the phenomena when a capillary tube of small diameter, very small diameter, open at both ends, exposed at both ends, is dipped vertically in water or any other liquid. Here we have just discussed water. Any other liquid, it can be mercury or any other liquid. So whenever this glass tube is dipped in water or any other liquid, there is two conditions or two cases what happens, two situations that can happen. Either there will be a rise in the level of the liquid in the tube with respect to the the normal level of the liquid in the container, or there will be a fall of the liquid in the tube below the normal level of liquid in the container. Okay, two cases. This is where there is a rise of liquid. Okay, there is a rise of liquid above the normal level, which is this is the normal level, and here there is a fall of liquid from the normal level. This is the normal level, and there is a fall of liquid in the tube. Rise of liquid in the tube or fall of liquid in the tube. So this phenomena of rise and fall of liquid in a glass tube of small diameter when it is dipped in a container consisting of a liquid of particular type, composition, density, etc., that is called as capillarity. And capillarity is the combined effect of cohesion, adhesion and surface tension. Okay, so we discussed about angle of contact. Okay, we discussed about angle of contact. So when angle of contact is lesser than 90 degree, it is called as acute angle of contact, and the resultant meniscus of the liquid is concave. It is because of higher adhesive force between the liquid and the solid container, leading to a rise of the liquid level at the ends and lesser cohesive force between the liquid molecules, causing a depression in the middle, leading to a concave meniscus or a curved shape which is bent downwards. This is acute angle of contact. Obtuse angle of contact, this is when the adhesive force between the liquid and solid at the boundary or the interface, the adhesive force is less. Okay, the adhesive force is less, and the cohesive force between liquid molecules is high, leading to a rise in the middle. We have discussed it in angle of contact. So angle of contact also plays a vital role in deciding whether there will be a rise of liquid in the capillary tube or a fall of liquid in the capillary tube. So capillarity and angle of contact. So a liquid whose angle of contact is acute, that is less than 90 degree, it suffers a capillary rise. Okay, this a rise above the normal level in the container. Whereas liquid whose angle of contact is obtuse, that is greater than 90 degree, it suffers capillary depression, fall below the normal level in the container. And the liquid whose angle of contact is equal to 90 degree, neither obtuse or acute, there will neither be any rise or fall. It will be same as the normal level of liquid in the container. So we will consider both the cases where there is a rise of liquid in the tube and fall of liquid in the tube. So here we have considered that we have placed a tube of radius 2r, radius r, diameter 2r in a liquid of density rho. Okay, and the angle of contact, which is in this case acute, between the tangent drawn to the curve concave meniscus and the interface of liquid and solid. Here for acute angle of contact, there is a capillary rise of height h above the normal level. Okay, this is the normal level. Okay, and there is a rise of liquid in the tube which is h above the normal level of liquid. Okay, so this is the normal level of liquid in the container, and this is the capillary rise H from the normal level to the point of where there is in the glass tube. Theta is the angle of contact, which is acute, less than 90 degree, and hence there is capillary rise. This is first case. Then in the second case, same diameter equals to 2r, where r is the radius, d is the diameter. Here angle of contact theta is greater than 90 degree, obtuse, and therefore there is a capillary fall of liquid in the tube below the normal level of liquid. This is the normal level of liquid in the container. Okay, liquid density is rho, and it falls below the normal level by the same h. Okay, capillary fall h from here to here. Okay, same things, density rho, obtuse angle of contact theta greater than 90 degree, capillary fall by factor h, and the radius of the tube is r, diameter 2r. So what is the value of this capillary rise or fall? So it has been found that this capillary rise or fall, it is related to surface tension force, angle of contact, radius of the tube, density of the liquid, and acceleration due to gravity. All these factors contribute to capillary rise or fall. So again, see how cohesion, adhesion, angle of contact, all these things, surface tension come into play. Surface tension is involved, so cohesive force, adhesive force will be involved. Angle of contact is involved, again cohesive and adhesive force are involved. This is the radius of the tube, which is the tube which is present, that's why it is affected by that. Liquid density, the composition of the liquid, that is involved, and this is acceleration due to gravity. So it has been found that the capillary rise or fall, that is given by this formula. H, whether it is capillary rise or fall depending on the angle of contact, is given by 2t cos theta by r rho g. T is the surface tension, theta is the angle of contact, r is the radius of the capillary tube, rho is the density of the liquid, and g is acceleration due to gravity. Okay, so here, as I was saying, how capillarity is related with first cohesion, adhesion, that is intermolecular forces, then surface tension, then that is surface tension T, angle of contact theta, and the other factors that are involved, radius of the tube, density of the liquid, and acceleration due to gravity. Okay, so here this is the capillary rise and fall, which is dependent on surface tension, angle of contact directly, and the other things which are constant, that is radius of the tube is constant, acceleration due to gravity is constant, and acceleration and density of the liquid, that is also constant. So the less the diameter of the tube or the narrower the tube, the greater will be the rise or fall of the liquid, okay, because it is present in the denominator. So less it will be, more will be the value of H. Okay, so less the value of R, more will the value of H. Depending, it will be capillary rise or fall depending on this value of angle of contact. So when it is lesser than 90 degree, that is acute, there will be capillary rise, and when it is greater than 90 degree, that is it is obtuse, there will be capillary fall below the normal level. So these are some of the basic concepts related to capillarity. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.